Today we're going to talk about motion and our solar system. And we've all known about the planets for a long time in school, probably studying since 4th, 5th, or 6th grade. So today we're going to take that topic and we're going to think about motion, what we've currently been studying as our essential question 8. Today I'm going to go through a couple videos that I want you to watch on YouTube to think about different ways that our planets are in motion. And then you can choose which way you want to answer today's question, which is describe planetary motion in our solar system. So I want you to take whatever you can from these lessons here and think about motion in our solar system. And you can focus on, all the planets. You can focus on the Earth and the Moon in relation to the Sun. You could focus on Jupiter, for example, and its 66 moons or whatever. But whatever you want to do, make sure that you talk about planetary motion in our solar system. All right, before we begin, what better way to begin than with a meme? And, I can't tell my corny jokes in class, so I figure I'll find a picture on the internet which can tell my jokes for me. So there you go. Okay, hope you're doing all right out there. I miss teaching you guys, and I hope that wherever you are, you're learning something at home, and you're getting something out of these, and finding something worthwhile during our distance learning unit here. All right, let's do a little overview of the planets all the way from the Sun to the Kuiper Belt out here. And we'll mention these other guys, these little dwarf planets. Remember, Pluto was demoted to a dwarf planet, but we have Ceres in here, which is around the asteroid belt, and Eris out here, and Makemake, looks like Makemake. But these guys are all considered dwarf planets. So think about the larger picture here now in our solar system when it comes to motion. And that guy right there, our local star that we call the Sun, is the reason why we're all in motion relative to that star. Also, you can zoom out a little bit. And we don't have any images of the galaxy. We haven't been able to get outside of our own galaxy, but putting together computer models from back in the day, we can take some kind of image here and some kind of composite idea where this is our Sun floating around in a spiral arm of this giant thing we call a galaxy. So actually rotating this way. So even the galaxy, our galaxy, the Milky Way galaxy, is rotating. So there's a couple websites I want you to look at if you can. They use Flash Player, so you might have to enable Flash Player on your computer if you can. If you can't, I know it's kind of a bummer. Flash is going away this year anyways, I believe, so they're going to have to update some of these things. But this My Solar System we might have used before in class. And if you go to My Solar System, you'll see that if I can go here, I'll copy that link and try to get it going here and see if I can show you this guy. Okay, so if you look at it, I had to click a few buttons. I don't know if you could see them where it said allow flash. You can play around with a little solar system here, and you can have a sun and a planet, a sun, planet, moon. And when you hit start, you can see this thing orbiting, and I know my screen capture software doesn't let you see the whole screen here. But you can show a grid. Okay, we can stop this, we can move this, we can reset, we can move this sun here. You can change the mass down here, maybe 500. It's just a relative mass compared to the other ones. You can change the mass of this guy maybe to 20, and the mass of this guy, let's say, to 1. The main idea here is you have a sun, a planet, and then a moon, and when you start it, you can see how that changes, and we can actually slow it down. So have a little fun with that. You can make your own solar system in a way. And remember, in this model, you have sun, planet, star, or star, planet, moon. And you can do some other things. For example, binary stars, where there'd be two stars, the yellow and the pink. Hit that thing and watch how this goes. Kind of interesting. You can take off the traces and just watch the objects move. So have fun with that if you can do that. Maybe you can learn about planetary motion through this module here. Okay, we'll let that go because an object in motion stays in motion. This one, the scale of the universe, is another one where you may or you will have to have Flash enabled. So don't get frustrated if you have to click something like this. We can click here. You'll hit allow. If your computer allows you to do that, you'll pick a language and then you'll hit start. And then you'll get some cool music here, hopefully. There we go. Nice little background music. And you can zoom in and out. So if you want to zoom in, you can go, that's kind of the things we were talking about at the beginning of the year, you know, with atoms and molecules and all this stuff as we go down here. If you zoom out, okay, you'll get out here, and then notice the background when it starts to get blue, that's like the sky, and then when it starts to get darker color, black, purple, that's more like space. So there you see West Virginia. Now you have Eris, one of our planets we'll mention, Europa, Moon, Io, Ganymede. All right, there's Mercury. There's Earth. All right, so now we're in space now. And you can zoom out and see. And then you can click on these things and read a little bit about them, their size. Just gives you an idea of their relative size, distance from the Earth to the Moon, etc. And then you find our star, the Sun. But then things get even larger if you zoom out. So I'll let you take a look at that. So that's the scale of the universe, and that gets you familiar with some of these objects that we'll talk about here in this mini cube. Okay, thank you. All right, next, there's a YouTube video here that I'll also post, which gives you an idea of the scale of the universe. It uses like a football field where the sun's here. It talks about relative distances using a football field, so we can kind of comprehend where they're at in the solar system and how far away they are from us. All right, this one, planets and stars, relative sizes. I'll post these YouTube videos as well. And they show you, once again, if you can't do the scale of the universe, I put this on here so you can see relative size. Okay, there we are on Earth here. There's Jupiter, right? So think about mass of Jupiter, and here's the other gas giant planets as well. And then here's the sun in the background. All right, so relative size is also something kind of interesting to think about when you talk about motion in our solar system. Okay, so that we can add that guy to our knowledge. And this video I'd like you to watch as well. This one isn't much when it comes to information, it's just a good visual. Remember, our sun is also in motion within our galaxy, that picture I showed you earlier. And our sun is moving around our galaxy, and all us planets, we're not that close to it in real life, but it gives you an idea about how we're moving, not just in that traditional stationary, sixth grade, 7th grade, 8th grade kind of model where we're sitting here with the sun in the middle and the planets orbit around in little circles. Imagine that the sun is actually moving and we are following it through space around the great attractor we call the black hole in the middle of our Milky Way. So look that one up if you want some interesting stuff. What's going on in the center of our galaxy is pretty cool to think about. The great attractor is what they call it. Okay, here's another slide. If you can't see the scale of the universe, once again, this just shows you the solar system objects, largest first being the sun, and then as you travel here, getting smaller and smaller. You know, Earth really is one of the largest things in the solar system, in our solar system. How about a quick tour through our solar system here? If you want some planets to look at, so we're on the notes here, slide 97. if you want to look at these, just to give you some data, let's just kind of flip through here and see these planets and some stats about their motion. Kind of interesting to think about. If you look at Mercury here, so I have each card, I've made a card where it says the distance from the sun in millions of miles, the distance around the sun, so how many miles it has to travel to make one orbit, the one revolution around the sun, so the length of its year. So Mercury takes 88 Earth days. Remember this whole idea of speed from yesterday's lesson with speed equals distance over time. Earth day is what we know as 24 hours. And if you think about this, it takes 88 Earth days for Mercury to make one trip around the sun. But look at the rotation time. This is where it gets interesting, and you can focus on any of these things if you want to for your question. 176 Earth days to make one rotation. So that means a day on Mercury, right? Look at that. A day on Mercury, their day from sun up to sundown takes 176 Earth days. And no moons. So another thing to think about, think of motion when it comes to moons. These closer planets tend to have lesser moons. And the farther away we go with the gas giants, they're larger, they have more moons. And then we go past those gas giants, those dwarf planets, once again have less moons than the gas giants. So once again, the relationship with star, planet, moon is an interesting one. Here's Venus's card. You can look through that. Looking at its moons, no known moons on Venus. Earth here, one moon. We're the only planet right around here that has one moon. And we're 93 million miles away from the sun. And that's pretty long distance, and it takes light about 8 minutes to get to us. Remember yesterday we talked about the speed of light, 300 million meters per second. So that's a long way away, and it even takes light, the fastest thing in the universe, 8 minutes to get to us. Okay, then we have one Earth year is one revolution, and then one Earth day is one rotation. Mars, there you go. 2 known moons, right? And feel free to look through these cards on the notes. Ceres is one of our dwarf planets, and for a while there in the 1800s, it was considered a planet before we demoted it to a dwarf planet. Some people even call it a large asteroid being around the asteroid belt. Our largest planet, Jupiter, here we go, it takes about 12 Earth years to get around the sun. So look at this here, 66 known moons. All right. Saturn also has a lot of known moons, 62. It takes Saturn 30 Earth years to make one trip around the sun. Uranus. All right, there we go. I'm sure there are plenty of memes out there about this planet. One revolution around the sun takes 84 Earth years. So I'm almost 40 years old. Uranus hasn't made it around the sun one time since I've been alive. Neptune is another gas giant. One revolution around the sun takes 165 Earth years. So now look at these millions of miles out here. Also, look at the rotation time, about 16 Earth hours to rotate one time. Remember, that means a spin, one spin. Pluto, a dwarf planet, it's way out there, 248 Earth years to make one revolution around the sun. It has 5 known moons, though, so there you go. Haumea is a dwarf planet you might not be familiar with, way out there. Okay, 2 known moons. It almost has this egg shape to it, we think, because how fast it spins. Look at that. About 4 Earth hours it spins around one time. So that thing somehow got knocked around in the early formation of the solar system and is still spinning. Makemake, once again, another fast spinning planet, dwarf planet, about 4 Earth hours. That's Makemake. And finally, Eris takes 561 Earth years. So that thing has made one trip around the sun, or the last time it made it came to the same point was about around when Columbus sailed the ocean blue. Think about that one. That's a long time it takes to make one trip around the sun. One day, though, on that planet is about the same as our day. So if you're into this stuff, I always recommend looking out on the internet. But there's a great book, Space Encyclopedia. This one, I love this book, one of my favorites, this Nat Geo Kids book. If you ever see this book at a book fair or you order it from Amazon, it's a great one. It has all this information plus a lot more. And I hope today you've thought a little bit about space. Watch those videos on YouTube. Check out the notes on Classroom. And then answer that question. Describe planetary motion in our solar system. And make sure you answer on Google Classroom. All right. I hope everybody's doing well. And make sure that, staying safe out there. Make sure that you look out for each other. Oh, this is all a temporary thing. We'll get back into our regular lives here soon enough. Okay, so have a good day today. And what better way to end the day than to talk about a song that mentions a planet. See you later. Till next time.